Happy Thursday, everybody. And yes, I'm recording this on Wednesday. If you notice that I'm wearing my shirt that I was wearing on Wednesday. Anyway, so today for math, you are going to be working on interpreting remainders. So it is long division word problems. And sometimes in long division word problems, you don't just write your answer. You don't just write 11 remainder 5 or whatever. You have to actually think about what it is asking you. Say, for example, in this example I have that they call it task 3. Landon will use beads to make necklaces. He has 623 beads and needs to use 8 beads for each necklace. What is the greatest number of necklaces Landon can make with 623 beads? So if you think about what's happening, he has all these beads and we're splitting them into groups. So it's like, okay, here's a group of 8 for that necklace. Here's another group of 8 for that necklace. So how many groups of 8 can he make out of his 623 beads? Well, if we have a question like that, where we're taking a whole big number and we're splitting it up into a certain number of groups, that is division. So let's do this division problem and then we'll think about what it's asking. So if I have 623 divided by 8. So we are going to do it by hand. So I think about, okay, my multiples, 8, 16, 24. Again, if you need to look up a multiplication chart to do this, that is okay. I'm blanking on the next one. 56, 64, 72. All right, so how many times does 8 go into 6? It doesn't. It's too big. How many times does 8 go into 62? If I look on my list, well, 64 is close, but a bit too big, so I need to go to 56. If I count, that's 1, 2, 3, 4, 5, 6, 7 times. Now I multiply 7, the number I just wrote, times the number on the outside is 56. Now I subtract. I have to borrow because I can't do 2 minus 6. 12 minus 6 is 6, and nothing. Now I can bring down my next number, 63. 8 goes into 63. Well, again, 64 is too big, so I need to go to 56. So I have 7 times. 7 times 8 is 56. Subtract. Can't do 3 minus 6, so I need to borrow. 13 minus 6 is 7. All right, so I have 77 remainder 7. Notice that's not even a choice on my list. So we need to think about what it's saying. Okay, well, we were splitting it up into groups, so I know that I can make 77 groups, and each group was one necklace. So I can make 77 necklaces. What does this extra 7 mean then? Well, if I'm taking the beads and I'm putting them into 77 groups, the 7 is what I have left over. Left over. So it's asking me, what is the greatest number of necklaces Landon can make with 623 beads? Well, he can make 77 necklaces. So if you see on the bottom part of this, next part of this sheet, there's sort of 3 options. Either the answer is the whole number quotient and the remainder does not impact the answer. Like this one here. The 77 was just our answer and we could forget about the remainder. Sometimes the answer is a whole number quotient plus 1. So say I had a problem like there are 10 kids that need to go somewhere. I can fit 3 kids in each car. How many cars will I need for all of them? Well, 3, that's 1. 3, that's another car. 3, 6. 3, that's another one. Now, I have this one extra little kid. Are we just going to leave him on the side of the road? No. Because if I did my division, and I was doing, okay, 10 kids, splitting them up into groups of 3. Okay, right? 3, that's 9. Remainder 1. So some people would just say, oh, the answer is 3. But then that poor kid is going to be left all alone. So I need to take this and I need to increase it by 1 to say I have 1 extra car. So in this case, I would need 4 cars. All right. Or say another example like that. If I had 23 books, I could put 5 in each box. How many boxes do I need for all of the books? Well, I'm going to take 23. I'm going to split it up into 5 groups, or groups of 5, sorry. 5 goes, it doesn't go into 2. 5 goes into 23 4 times. 4 times 5 is 20. Subtract, I get 3, remainder 3. So I'd have 4 full boxes, and then I need 1 more box for those extra books. So I would need 5 boxes. All right. So that's sort of the second type where I take my answer and I add 1 because I need 1 extra something, even if it's not full. And then sometimes our third option is just that the answer is the remainder. Like in that first problem, if it had said, how many beads does Landon have left over? Or in this problem I just wrote, 5 books in each box. How many books would be sort of left over, not in a full box? Well, 3 would be not in a full box, right? So just depends on what they are asking. So there are 8 problems for you to work on. Sometimes you can draw a picture, but sometimes a lot of these numbers are too big, so it'd be a little tricky to draw a problem for them. But you can think about what it's asking. So problem A, a bakery is packaging cookies into bags of 8 cookies. Okay, so we know, okay, each bag has 8 cookies. The baker has 154 cookies. Okay, so he has 154 that he's putting into these bags. How many complete bags of cookies can be made? Well, if I'm splitting it up into groups, I know that's division. Hint, all of these are going to be division. So if I do 154 divided by 8, doesn't go into 1, goes into 15. Well, 16 is 2, so that's too big, so just 1 time. 1 times 8 is 8. Subtract, I get 7. Bring down the 4. If I were looking on a multiplication chart, how many times does 8 go into 74? Maybe you know your facts. I know that 8 times 9 is going to be 72, which is very close. Okay, so 19 remainder 2. That's not what I write in the box, though, because what it's asking is how many complete bags of cookies can be made. Well, I know 19 is how many full groups I'm going to have, and then I'm going to have 2 cookies left over. So how many complete bags will we have? We'd have 19 complete bags. Now, if we wanted to put all the cookies into bags, we would need 20 bags. We'd increase it by 1. But what this is asking is just how many complete bags can be made, which is 19. So, if you need me to do more examples, if you have more questions, that is fine. Just let me know.